Good afternoon, everyone, and welcome to December's Sheffield DevOps. We're very happy to have you with us. A quick reminder, as always, we do have a code of conduct here. It matters a little less on our remote online-only meetups, but it still does apply. So if you see anything that doesn't fit with that code of conduct found at sheffielddevOps.org.uk/COC, please let one of the organisers or speakers know, and we will do our best to address it. We've got a fantastic talk today from Matt, who's going to be talking about Git. If you do have any questions throughout the talk, or even at the end during the Q&A, if you hear a discussion point you want to hear more about, please drop your question as a comment on the YouTube video where you are watching right now, and we can highlight that comment and get it answered. We are still looking for talks. We have our January talk confirmed, which is great, and there'll be more details on that a little later on. But February onwards, we are looking for speakers. So if you have a good idea for a talk, check out our website for some of the stipulations around talks and get in touch, because we would love to hear your stories. One final bit, please follow our page on LinkedIn. We need a few more people to like us on LinkedIn before we can stream to LinkedIn as well. So by doing that, we can increase our engagement, increase our reach. So any recommendations that you can give to people to follow us will be greatly appreciated, because it means that, as I say, we can get a better reach when we do stream our events. So I am going to introduce Matt. I'm going to bring Matt onto the stage now. Hello, good afternoon.
Hi.
So Matt is going to be talking about Git. He's worked with Git, it says in his bio, since 2008. I don't know what I was doing in 2008, but it wasn't working with any sort of version control. So he's delivered Git training to hundreds of technical and non-technical people, managed complex transitions from other, dare I say, inferior version control systems, or just different. We'll go with different. We'll be politically correct about it. And is passionate about helping people use Git more effectively. So, as I say, I've had a sneak peek of this talk, just going through the inner workings of the streaming platform, and it looks great. So, Matt, are you ready if I hand over to you?
All ready to go.
Cool. I will leave you to it. Thank you very much.
Okay, good afternoon, everybody. So it's fantastic to be here to have this opportunity to speak to you about Git, which is hands down my favorite item of technology I've ever used. As Oliver was saying, I've worked with it since pretty much the beginning of Git's inception as a technology, and done a lot of training and transitions work with it. So I'm pleased to have this opportunity to talk about it today. I have done virtually every job you can imagine in the tech industry, from answering phones in tech support, have you tried turning it off and on again, to QA, to some management roles, some DevOps stuff for the last sort of 15 years or so. So I've done a lot of stuff with Git. And what I've found is nowadays, almost all techies of the sorts of persuasion of the people that will be on this stream, most of us use Git nowadays. We are familiar with what we need to do to get the basics of our job done. But I've found that even though it's become ubiquitous, it's on almost every job spec that you see, you need to have Git skills and stuff, I still find that a lot of people don't really understand what's going on. Back in 2014, if I bring this one up, XKCD did this. Let's shift. So I should mention, while you're looking at that XKCD, I've done loads of this stuff, but this is my very first time streaming or anything. So a couple of days ago, I learned how to use OBS. I might get the keys messed up. It might completely collapse in a heap, but hopefully we'll have some fun. And yeah, this XKCD here was in 2014 or so. And back then, people were saying, well, I didn't know how to work it. I don't know. I know it's cool. I know it's got this great object model behind it, this graph theory model. but most people just memorize shell commands and type them. And if they mess it up, they delete it and start again. I think what has changed since 2014 in not the majority, many people's usage of Git is that instead of memorizing shell commands, we've come to memorize buttons to click in our IDE to do stuff. And when it gets messed up, you go and talk to somebody else and say, what do I do? And they'll say, delete it and start again. Because people that really understand it, not so many of them. So what I'm hoping from this talk is that we will build from the ground up a mental model of what Git is doing when you do the standard things like add, commit, push. And then we'll look at why it's doing things the way they're doing and how you can benefit from that. Now, one of my previous jobs, I was a school teacher teaching like 5-year-olds up to 16-year-olds. And it's impossible to scratch where absolutely everybody really wants you to do. So we're going to start simple and we'll build up, and hopefully wherever you are in your journey as a Git user, you'll get something from today's talk. But obviously we can't cover everything in a half hour or so. So we'll do a work example with the owner of the White Rabbit sandwich shop. Why White Rabbit? Because originally when I used to do this training, I had a matrix screen in there, and like Neo holding out, Morpheus holding out the red pill. I said, Git is the red pill. It's the thing that will change how you think about version control. But then red pill became kind of associated with toxic masculinity. Don't want anything to do with that. But I've still got White Rabbit. Forgive me for that. So here we got our guy, the owner of the White Rabbit sandwich shop. Maybe I did this at lunchtime. I was hungry. I'm still peckish now. I want a website, he says. So we'll give him a website. I'm a back-end guy. Pretty much the only thing I've never done is front-end stuff. So that's the extent of my HTML knowledge there. The White Rabbit sandwich shop in a H1 tag. Visit us for our lunchtime wonderland. We've created his website for him, and we're going to track that in Git in this worked example. So there we've got White Rabbit directory, index.html, and that's in our working directory. So what we're doing is building up some concepts. The working directory is where your files that you're currently working on are, and we're going to set it up for Git. So Git init, and it's going to respond with initialize an empty Git repository, Git add index.html, Git commit. Now, most of us probably on this talk, we've all used Git to that extent, I would expect. Although if you want some more background, hit up in the comments, let me know how you want me to ping things. So init creates the repository, adds the file, commit the file, get a log, we get a commit ID, we'll come to what those are in a minute, and the author. So what's actually going on when we do that though? Well, initially import, there's our log. So what actually happened, we've done our Git init, and a directory has been created alongside our working directory, a hidden one with .git, and it contains a hidden folder full of stuff. What is this stuff? We're going to come back to it in later, but for now, mental concepts first, laying the foundations. I want you to think of it as this, the staging area and a local repository. So that staging area, the correct name for that is the index, but we're going to call it the staging area throughout this because that is really what they should have called it. And the local repository. Staging area is with temporary storage for changes about to be committed. And the local repo contains the complete history of every commit you've ever made. Some of those, if they get sort of orphaned, might get pruned out at some point, but pretty much anything you've ever done, including any complex operations you might do on that repository, they're still there. So we've got our working directory, our staging area, our local repository, all inside the White Rabbit directory. When we add it, we're adding it to the staging area. You've probably seen this diagram, with the git add, push, all that kind of stuff. So hopefully this won't be too new to you. We copy the file into the staging area. Git add is not forever. Now, I used to label this point because back when I started training people in Git, they were used to things like Subversion and CVS. Crikey, anybody on the call on the stream remember CVS? That was ancient, horrible version control system. If you wanted to create a branch, it would take all afternoon. But git add works differently to say svn add. With Subversion, if you add a file, you're saying, for the end of time, track changes to this file. I'm going to do a commit. include these changes in it. But with Git, it's not forever. That might sound dumb, but it really isn't. Imagine this. You hack away on feature X, you hack away on feature Y, you hack away on fixing bug Z. You can add the files for feature X, commit those. You can add the files for feature Y, and you can add the files for your bug fix to separate commits. Maybe you could even put them in different branches if you want to, because sometimes the way that we work, particularly when you're in flow, when you're just like 3 in the morning, you're still going. I've been there quite a lot. You might actually do things in the wrong order. People will complain, and they used to complain about Git being able to rewrite history, and maybe people will be scared of rebasing, and we'll come to that. But this flexibility of the staging area to let you put different changes you've made into different commits, that's one of Git's key advantages, in my opinion. So git add means take a snapshot of the file exactly as it is right now and put that in the staging area. So git add is not forever. So we've got our working directory with visitors for lunch in Wonderland. In the staging area, we've got that. We're going to do a commit, -m, initial import, and there it goes into the local repository. The staging area is emptied, and it's into the local repository in a commit. We do a git log, we can see what's happened, and we've got a commit ID. We're going to come back to why they are what they are, how they work in a few minutes. So as owners of sandwich businesses are frequently want to do, he wants a change. If it wasn't for clients needing changes, well, we'd all be out of jobs, wouldn't we? And I am, so if you want to hire me, hit me up. So call us, he says, call us on that number. We're going to make a change. White Rabbit Sandwich Shop, we're going to make the change in our working directory. It's now different to the version in the local repository. Git status will tell us what's going on. Tells us that there's a change to index.html. Why does it know about index.html? Because we have added it before, but we'll need to add that again if it's going to be in another commit. So git diff will tell us what's the difference. If you're a more advanced Git user and you're not already using git diff tool, that's something to look into. I'm not going to cover it in this session. Git diff tool, useful to get a visual or vim diff based difference of the changes. So we'll do a commit. Oh, we'll do a commit. Sorry. And added the phone number, but what does it say? Oh, yeah, sorry. I skipped a page forward there. Git add is not forever. Yeah, if you stick -a on the end, it'll work even if you haven't done the add. But I think because the possibility of doing something you didn't intend, if you're using -a, I don't think you should do that. It will not include new files you haven't already added. And I think sooner or later, -a will bite you, so don't get used to it. It might not bite you today, it might get you tomorrow, but it will get you soon. So git log, we've got a couple of commits in there. The first one, we've made a change to add our phone number for the sandwich shop, and that's all in. Let's look at these commit IDs. We can usually take the first 7 or so. There are possibilities of collisions, but they're very unlikely. So where do these commit IDs come from? To answer that, we're going to need to look under the bonnet. And this is my old M3. I loved this car, and when it exploded, dropping oil all over the M1 about 3 years ago, I was absolutely gutted. And that's all I've got left for it is this photo. So we're going to look under the bonnet. Git's objects, the primary ones I want to cover are blobs, trees, commits, and references. What's a blob? A blob, binary large object, stores file contents. One key difference to some earlier version control systems is that the entire contents of every file is going to be stored in one of these blob objects inside the Git directory on your machine. That should tell you a few things. Firstly, because it's all there, we can do direct diffs without needing to go to a server. But secondly, it should tell you that Git isn't necessarily the right choice out of the box if you're going to be handling really large files. There are ways of doing that. We can talk about those later. But every file is going to get turned into a blob object inside your Git local repository. So imagine we've got the text of the Declaration of Independence there. We hold these truths to be self-evident. We create a commit. Before the commit object is created, a blob object will be created. That's full contents, not the deltas, not the difference between the previous commit and the next one. It's the whole contents. If you have the version of our sandwich shop HTML without the thing and the one with the phone number, both of those, 2 blobs. The contents gets compressed. No, there's no file name in a blob object. It's just the blob itself. That allows for tracking files to be moved around. Every Git object has an ID, not just commits. And every blob that you create has a hash. I'm just going to shout out to a WSL window. Right, so here I am on local machine. Create a file called hi, git hash object. This is the command you won't use very often. It's used internally. They used to differentiate between the plumbing, things like hash object, and the porcelain. That's sort of gone by the wayside a little bit now. But hash object, hello.txt, is going to give you the hash of that file. And that will always be the same for that input. If you put exactly the same file on your machine and did git hash object, you would get exactly the same hash out of it. It's not a commit ID. That is the blob ID for hello.txt. Let's see if I can get back to my PowerPoint without ruining things. Yes, we're good. So tree objects, they store pointers to blobs with the file names this time and to other trees. So that's how nested folders are created. And primarily out of blobs and trees, you can build the content addressable file system of Git. So there we've got our Declaration of Independence text and the README file. They're each blobs, and the file name and the blob reference is stored inside the tree object. So this is from the Git documentation. Since trees and blobs, like all other objects, are named by the SHA-1 hash of their contents, 2 trees have the same SHA-1 name if and only if the contents, including recursively the contents of all subdirectories, are identical. This is why Git got a reputation as being hard to learn, because the docs are precise, they are detailed, but they're not always that easy to understand, and people run off screaming. Here's what it boils down to. Change anything, even 1 byte anywhere, and the tree's ID will change. So if you move a file around, the tree is going to be different. Therefore, the commit that gets generated from that tree is going to be different. A commit object, bringing to that, links a tree with 1 or more parent commits. Well, actually 0 or more. The first one will have 0 commits, 0 parents. And other details about the change, who did it, when they did it, what message they've given. So we've got blobs, we've got objects, we've got blobs, we've got trees, and we've got commit objects. If we were to do this set here, echo hi, bye, git commit, we've got our commit object that refers to hello.txt, the tree that contains hello and bye, and these 2 blobs. And if you did exactly this, I think, but I haven't tested this since 2014 or so when I first made this slide, but you'll probably get these same numbers. Be interesting to try that. So the blob for hi goes there, the blob for bye goes there, and they both commit, go into that commit tree. And all of that information in all the subdirectories and files, the entirety of it makes Git, the commit ID, what it is. So the only thing you need to track changes to repository is that commit ID. And we can graph repository history using just that. I'm conscious of the time. We're already, does it really? I just noticed in the chat that OpenBSD still use CVS. My goodness. So I'm conscious of the time. We're not going to get everything covered that I wanted to, or I need to talk a lot faster, which probably is counterproductive, but we'll see how we go. So these arrows, they're not pointing in the wrong direction. Commits only know their parents, not their children. So the tree needs to be traversed from that side. If 2 commit IDs match, you know they're exactly the same. They are just like these 2 baby twins. And a reference, the last object we're going to cover, is just a pointer to a commit. So if you were used to an older version control system where branching was expensive, for example, then this would be a major change. So if we've got a reference that points at a commit, that a branch reference moves automatically each time you make a commit. And head is a special reference that always points at the current branch. Whereas tags are references that stay put forever. So if we looked inside that Git directory with the branches config description folder, the blobs, trees, and commits are stored inside the objects directory, and they're done so in a manner that's efficient for storing a large number of these inside one directory. Say that you had a Linux file system, X3, whatever, with 49,000 files in it. Doing an ls on that file, depending on the speed of your machine, might take too long. So the way that Git works inside that objects directory, if we look inside it, .git, there's objects, it stores 29 FA3B, first of all in 29, and then in the rest of the hash. So there's no wasted space, but the first two characters are top level directories. A gotcha, if you've ever created a Git directory locally as root, is that the objects directory will be owned by root, and that can mess things up because these directories, these 29s, whatever, won't be owned by your user. So branches and tags are text files. That's why it's so cheap to create a branch or a tag in Git. You should do so freely. Now, we're not going to get into discussions about whether you should do your development on feature branches or trunk-based development in this conversation. But because these references are just text files inside the refs directory, it's super cheap to create one. If we cat head, it just points at refs heads master. And we cat master, it's pointing at the commit ID that master is pointing at. So branch is just a single file on disk. Older things, we're not talking about those too much. You've got 1, 2, 3 monotonically increasing version numbers. You can only stick 5 on the end, but in that system, you can only have one parent to each commit. But here with these two commits, you can branch from anywhere, just creating a new text file. So you create a branch with git branch, and you switch them with git checkout. So we've done git branch experiment, git checkout experiment, create a new file, add the file, and that commit will be on the experiment branch, whereas master stays where it is. If we switched back to master, then the file we've added on the branch will be disappearing. So here we've got, I'm not using commit IDs anymore, just see commit 0, commit 1, whatever. Create a new branch. Do some more commits on that branch. Check out master again, heads moved away. And we fast forwarded. So there we've applied our new commit C2 and C3 on top of C1. It's a merge, but it's not really a merge. It's a fast forward. Doesn't happen that often, unless you're doing trunk-based development, I guess. Simple fast forwards don't happen that often. So go back to before the merge, and we'll see what's happened when there's some intervening commits on master before we are ready to bring in ours. So C4 and C5 have been added to the master branch, and we want to bring in C2 and C3. And in this model, I don't think this is the best way of doing it. I'm just explaining how it works. We're going to bring in a merge commit, bringing in C2 and C3 with the C5 as the parent. So, and C6, C3 as the parent. So check out master. Git merge branch 1 is going to do a 3-way merge on C1, the ancestor, C3, and C5. And it will do its level best to need no intervention on this. Just behind my head there, it says, and usually succeeds. So C6 is a merge commit. It's got 2 parents. Its parents are C5 and C3. Merge commit created by Git with 2 parents. We are going much slower than I intended. I'm sorry, I'm not going to get to all of my content. If something goes wrong with a merge, Git reflog is your friend. It'll show you all the commits you've changed along the way. And most conflicts will get resolved. If you recognize this film, I'm your friend. If you recognize this film, well, I'm probably not your friend. Yeah, I am. For more complex ones, Git turns off the autopilot and let you sort them out. And you've probably seen the conflict markers. Right, Git rebase. Let's get into some slightly juicier stuff before I completely run out of time. Git rebase, juggling chainsaws. In the manual, it says it forward ports local commits to the updated upstream head. Yeah, everyone knows what that means. It puts a copy of the commits on the current branch on top of the latest commit of a different branch. Now we're getting to the category where not every Git user would know how to use it. Rebasing is fun to watch, but it can look dangerous. If you screw it up, Git rebase minus abort. You don't need to delete it and start again. That's what you do. So we've got the same set of commits, but this time we're going to do a rebase. And yeah, what? Slow down. What's going on there? It's still hard to follow. We're going to go through it in step by step before our brains go kaboom. So we've got master at C5, branch 1 at C3, and branch 1 is checked out. We're going to do Git rebase on master. This is the style of development where you've got your feature branch locally and you want to bring it up to date with things that have been happening on master since you last branched. Again, it would be great to have long discussions about the right way of doing this, the right workflows to use. I've got some strong opinions there. But for now, we're just saying that we're going to do a rebase workflow on these two commits. Rewinding head to replay your work on it. So head's currently at C3. We have to take it back to C1. To do that, we need to move C2 and C3 out of the way. So they are now out of the way. And branch 1 and head start pointing at C1. Now we're going to apply the commit message for C2, but notice C2 is still down there. This is a new commit with the same content and the same commit message. And at this point, we've got one of our commits brought on top of C5. And we do the same thing with C3. Again, it's a copy of commit C3 with the same message, but a different parent and therefore a different commit ID. So Git has created two new complete new commits, different parents, different commit IDs. Eventually, and you can configure how long it will take, C2 and C3 will get deleted. If somebody had a branch based on C2 or C3, that's what you've done. You've done a Vinnie Jones on them. So don't ever rebase a published branch. Now, I'm not going to do remotes. Let's skip through all of that. What I am going to do is yeah, that's my opinion, rebase during dev merge when features are ready with a short-lived branch as possible. Let's go back to here. Right. I'm going to get rid of RM of hello.txt. Git add. Everyone see the text all right? Is it not too small? Hopefully. Speak up if not. Git add apple.txt. Oh, we need to get in it first, don't we? Git add apple.txt. We'll do cherry.txt. Yeah, let's do that. Notice I haven't talked about IDEs because it's my conviction that if you learn to use the basic CLI tools, you'll understand what's going on better and you won't get stuck. What I'm building up to doing before the end of our time in this session is a interactive rebase. So I've added apple.txt. I'm going to commit that. And I'm going to add cherry. Git add cherry. And if we do git log, we get added apple first, added cherry afterwards. Let's add a banana. You can probably see where we're going with this. Git add banana.txt. And we've got apple, cherry, banana. I don't like the sound of that. Let's reorder them. This is where understanding what's going on with the rebase is helpful. Bonus tip, cat my git config. If you didn't know this, git config can store aliases. And this one, I'll paste this into the chat later, is my preferred Q log here. An alias for a log format that just works for me. So I can see that I've got apple, cherry, banana, and I've got a shell alias pointing at git Q log, same thing. So glh git log to head is what I'm doing there. So imagine I want to reorder those commits for some reason. Maybe I am I've done a bit of development and I've got something in there that shouldn't be there. It should be on a different branch, different ticket, whatever. So git rebase -- interactive. Because I haven't got a master branch anywhere, have I? You know what? That isn't going to work. And Ollie, you said I shouldn't do an interactive rebase. Yeah, crikey. No, I'm not going to do that, am I? Okay, let's think. I can probably create a remote as another branch, as another directory. Right, I'm going to do a bare repository here, like this. That has no working directory in it. I'm going to cd back to Sheffield DevOps. Got no add. So bar, and I think I'd be okay to go ..bar. Good. I'm going to push to that. There we go. I would have thought an interactive rebase would work without having a remote. Is it just because I missed off master? That's all it is. There we go. What? Ooh. There we go. Right. So I've only got I've got the demo effect here. I should have done a test of this before I got this far. I do apologize. Why is that not giving me the option to interactively rebase? Yeah, okay, we'll drop out of that. Back to my PowerPoint. Maybe not. No, I don't know what I've done wrong there. I was expecting to see a list of commits and be able to reorder them. So what you would do if they were listed there, you could choose to pick or just reorder the commits in that list. Sorry for that unexpected technical hitch. I am going to open up for questions at this point. Thank you.
Hello again. I think that's probably my fault for cursing you with the demo gods by saying,
yeah, you did.
Yeah, I said, are you got a pre-record? What we can do, I'm sure we can do this, Matt, is if you record the rebase as you're, in non-stressful situation, and I think we should be able to just tag it onto the end of the video, or splice it in. I don't know. We could pretend demo work. We'll record two versions. Great demo. And we can just, I think we should be able to just splice it in. Yes, so thank you for that. Pop your questions for Matt in the chat if you haven't already. It's really interesting. I found this really interesting because I'm one of those that didn't learn Git in its pure form. I learned Git purely as a tool to do what just needed to be done at the time. So my question was around Git stash, because I've often just gone, oh, I need to change branch. Oh, but I've written something on this branch. I don't want to commit it yet, but I need to do something on another branch, and just Git stash and forgot about it. And then come back in a few weeks and, my stuff's gone, or I can't stash again because I've already stashed. Like, how's Git stash work?
So Git stash will take the change. Let me get one of my earlier slides where we had the staging area and stuff. Okay. So if you've got changes in your working directory that are not part of a commit and you couldn't work with those straight away, Git stash will put those in like a temporary area that's not the staging area, so that you can then continue with other changes. So they're just stored in a temporary out of the way area, and you can apply that stash or you can pop it.
So what Git stash is then is it's essentially yet another area within your file system for things to go and be forgotten about, basically.
Yeah, I suppose it could be. Now, if you had like a prompt set up to show you what you had stashed and what you didn't and stuff, let's do an example of that. Oh. What's a fruit beginning with D? Durian? Crikey.
Everyone's favorite fruit.
So at the moment that's in there. If I do a git stash, it doesn't. Why is it not doing that? I am being cursed by the demo gods. I'm not quite sure why, because I've got apple, banana, and durian. Git stash ought to make my durian disappear. Yes, that's what ought to happen, but it isn't happening for me. Demo's curse.
Typical. No, what we'll do with the demo, then we'll get it recorded.
Should have done, yeah.
A lot of these tools, I've only used them in anger, especially things like the rebase, where like you alluded to earlier, you do what you can, and then you just call on the person who knows Git most in your organization to fix whatever mess you've made. So, you know, it is really useful to be able to understand exactly what these, as you say, the pure form of what Git is doing. I don't suppose you saw, there was this project from Drew DeVault a few years ago now. He basically re-implemented the Git command line in Linux shell.
Okay.
So rewrote everything as like shell functions.
Okay.
Including doing all the hashes and all that sort of stuff. He live streamed, or at least recorded the stream of him doing it. So that might be worth, you know, a bit of further viewing for people as well. Because again, that was understanding, you know, what's happening at the OS level, rather than it being abstracted away, as you know, people are used to now. Okay, so if there's no further questions for Matt, we'll leave that one there. You know, if you watch back later and you have a question, feel free to drop it on the stream or the video, and I'm sure Matt will be hiding in the comments. If people want to send you questions outside of this stream, what's the best place for them to get you?
Hit me on LinkedIn, linkedin.com/in/Tidzo.
Wonderful. So thank you very much. All that remains now is to have a brief little insight into what's coming up next month. So next month we've got Will Wilson, who's joining us. He's going to be talking about chat ops. So, you know, as part of this whole Git flow, right, you create a branch and push it up and create a pull request, and that appears in a Slack or a Teams channel somewhere to say your attention is needed. So it's great how these all kind of fit together. So yeah, that's coming up next month. I think it's the 7th. I made this mistake last time, Matt, as well. I didn't check the date of the next meetup before announcing it. Second week in January, so it's the 9th of Jan. Is when we'll be talking about chat ops. All right. Well, thank you very much. It's always a pain when a demo doesn't go to plan, but we can, as I say, we'll record it and share it, and you know, hopefully by the time people watching this back, it's all there for them to see. Right. Okay. Thanks very much. Take care.
Everyone.